Hello everyone, I am Siu-Ho Yu, an undergraduate student from the Electrical Engineering Department of City University of Hong Kong. I have participated in the department's technical training program this June. In today's video, I would like to share what I have done and learned during one of the 5-day modules I took. To start off, let me introduce what I have done during these 5 days. The module I taught was named Raspberry Pi and Internet of Things. We used the Raspberry Pi model, which is something like a palm-sized computer, to make different applications. For instance, we can connect the Raspberry Pi to a monitor and use it as a host. With Raspberry Pi as a host, we can run programs on it and make use of the hardware components connected to do different applications. I will cover these later in this video. The training program allows students to apply knowledge taught in courses to real life. This program helps students to better understand knowledge learned and have a taste of how the knowledge learned can be used in future careers or studies. Let's move on to talk about what I have done during the 5 days. On the first day, we started familiarizing ourselves with the Raspberry Pi. The technical staff introduced to us what Raspberry Pi is, its structure, applications, and what are we going to do with it in the coming days. Then, we download necessary packages and software. At first, most of us have never used a Raspberry Pi. The focus of the first day was to learn how to use the command lines to communicate with the data and network control of the Raspberry Pi. For example, create, delete, move, and renaming files and directories in the file system, building connections with another computer, allowing remote control and file transfer between computers. The highlight of the day is to understand the roles of users and root user. For example, the root user is privileged in doing modifications to the computer, having power to modify configurations and installing packages to the Raspberry Pi. Moreover, we had a simple revision on Python because some parts of the Raspberry Pi can be programmed by Python code for different applications. On the second day, we moved on to the application part of the Raspberry Pi. The first application we worked on was the camera module. We took photos and videos with the camera connected to the Raspberry Pi. Then, we learned to control the settings of the photos and videos to be captured by the camera. After successfully doing the exercise, we moved to more challenging tasks. The highlight of the day must be the object detection. We programmed the Raspberry Pi to frame objects in the camera field and identify them. For example, identifying names of food, animals, and domestic appliances with their photos. Although we didn't get really accurate results due to limited tracing of the Raspberry Pi under time limits, it gave us a deeper understanding of how objects or events in a live camera are identified by the system. Moving to the third day, we continue to explore other applications, namely the optical character recognition, OCR. We first provide images with characters or numbers to the Raspberry Pi. Then, we ran packages to read and identify characters on the images so as to learn how OCR works. Then, we explored how it can be applied to read not only still images but also words appearing on the live camera. Through these tasks, we learned about how to improve the performance of the OCR application. We need large amount of data to feed and train the computer, and monotone images or captures are better for recognition. Resizing the target image can also be a choice to enhance performance. Coming to the fourth day, we move on to interactive applications of Raspberry Pi. Raspberry Pi has built-in sensors to detect environmental information as well as changes made to the body of the Raspberry Pi. Moreover, there is a joystick which allows the users to input to the Raspberry Pi or even control the cursor on the Raspberry Pi computer. We have made 3 different applications using these special features of the Raspberry Pi, namely Snake Game, a compass, and a reaction game. In particular, the Snake Game is similar to the classic Snake Game, in which players use the joystick to control the snake to eat the apples as displayed on the LED matrix display unit. We also made a compass using the magnetometer in the Raspberry Pi to detect the direction it is turned to and display the results with the LED. In the reaction game, an arrow will appear on the LED pointing in a random direction. Players need to tilt the Raspberry Pi to the indicated direction. If they fail to do so in 3 seconds, they lose the game. These interactive games surprised me in the capability of Raspberry Pi in doing different tasks. The sensors, display, and joystick can mix and match to serve different purposes. Coming to the last day, we set up our own local database server. We collected data with the Raspberry Pi and upload the results to the database. In addition, we created our own web pages and showed our data collected on the web page using PHP codes. During the construction of the server, database, and web pages, I have learned how different parts in the local server are connected and how data and information flows in between. I think this was the highlight of the day. Not only Raspberry Pi and normal computers can play the role of a host, they can also be part of the Internet of Things, so as to build a network that allows flow of information. In a nutshell, this training program has widened my horizons and deepened my understanding of IoT. By connecting different components into the network, we can work with more applications with it. Within the Raspberry Pi, there are a series of components: sensors, LED, camera, and joystick. While Raspberry Pi itself can also be a part of the network. It can be controlled by another computer. The data collected can be sent to the database. I think I've learned a lot finishing the tasks in this module. Thank you for watching this video. Bye bye.